Let us take one more example on nth derivative of the function. We have to find the nth derivative of y is equal to x to the power 4 upon x minus 1 into x minus 2. We have given that y is equal to x to the power 4 upon x minus 1 into x minus 2. If we multiply this term, x into x minus 2 minus 1 into x minus 2, which is equal to x to the power 4 upon x square minus 2x minus x plus 2, and which is equal to x to the power 4 upon x square minus 3x plus 2. If we see this expression, the power of numerator is 4 and the power of denominator is 2. So such type of algebraic fractions or expressions are called improper fraction. There are two types of fractions. This is called, if we have written like that, 1 upon x plus 1. So here the power of numerator is x to the power 0. We can write down 1 can be written as x to the power 0. So power of x is 0 in the numerator and the denominator power of x is 1. So such type of expression is called proper fraction. Proper fraction like that. We can also write down x plus x square plus 1, x square plus 1 upon x cube plus 3x plus 1. So these are the examples of proper fraction where the degree of the x in the numerator should be always less than the degree of x in the denominator. This is called proper fraction. But if the degree in the numerator, for example, in this example, here the degree of x in the numerator is 4 and the degree of x in the denominator is 2, highest degree. So this type of expression is called improper fraction. If we want to find out the nth derivative of any fraction, algebraic fraction, then we have to first convert that improper fraction into the proper fraction. So how it can be converted? So let us just see here. We have to just divide that by using the division formula, division method. So we have x to the power 4. X to the power 4 should be divided by x square minus 3x plus 2. So if we multiply this by x square, this will become x square into x square minus 3x plus 2. This can be written as x to the power 4 minus 3x cube plus 2x square. This is the expression. Now we subtract it. So minus plus minus. This will cancel. This will cancel. We have 3x cube minus 2x square. Now again this is 3x cube. So what should we multiply over here so that it will become 3x cube? We will multiply by 3x. Multiply this x square minus 3x plus 2 by 3x. 3x into x square minus 3x plus 2, which is equal to 3x cube minus 9x square plus 6x. Now again we subtract it. So this is 0. Minus 2x square plus 9x square is 7x square. And this is minus 6x. Now this is 7x square. So we have to just multiply this by 7. 7 we are multiplying. So this is 7x square minus 7 3s are 21x plus 7 2s are 14. Now if we again subtract it, it will be 0 plus 21x minus 6, which gives us 15x minus 14. Now here the power of x is 1 and here the power of x is 2. So this is the last term, or we can say that this is the remainder. Now we can write down this expression into the form of what is this value x square plus 3x plus 7 plus remainder divided by x square minus 3x plus 2, which can be written as x minus 1 into x minus 2. Let me take one example. Suppose we have 5 by 2. So 5 by 2 is not a proper fraction. It is improper fraction. Why? Because denominator is less than numerator. So we have to divide it. So 2, if we divide 5 by 2, 2 to the 4, 2 to the 4, it is 1. So we can write down, this can be written as 2 plus 1 upon 2. In the similar manner, we can write down this x to the power 4 upon x square minus 3x plus 2, which is equal to, what is this part? X square plus 3x plus 7 plus what is remainder and divided by this value. So this expression actually, which is not in proper fraction, can be converted into the proper fraction. Now we are able to find out its nth derivative. So let us go ahead. Let 15x minus 14 divided by x minus 1 into x minus 2. We want to find out the partial fraction, because if you want to find out the nth derivative of 1 upon x minus 1, x minus 2, it is not possible. So we want to do the partial fraction. So let us write down 15x minus 14 upon x minus 1 into x minus 2, which is equal to a upon x minus 1 plus b upon x minus 2, which implies 15x minus 14 if we simplify it, then a times of x minus 2 and b time plus b times of x minus 1 whole divided by x minus 1 into x minus 2. So both will cancel, and now we have the equation 15x minus 14 is equal to a times of x minus 2 plus b times of x minus 1. Now this is not only an equation, this is called identity. So if we see what is the difference between equation and identity, equation is true for some particular value of the variable, but identity is true for any value of the variable. Now here, since this is identity, so it is true for any value of x. So if you want to find out the value of a unknown quantity a and b, let us first put x minus 1 equal to 0. If you put x minus 1 equal to 0, then this total term will become 0. And x minus 1 equal to 0 means x equal to 1. So this will become 15 into 1 is 15 minus 14, which is equal to a. 1 minus 2 is minus 1. So let us go ahead. This is an identity. So it is true for all values of x. Putting x minus 1 equal to 0, which implies x equal to 1 in equation number 3. 15 into 1 minus 14. We have to put x equal to 1. A into 1 minus 2 plus b into 1 minus 1, which is equal to 0. We can simply, if we simplify it, 15 minus 14, which is equal to 1 minus 2 is minus 1. So minus a plus 0. 15 minus 14 is 1, which is equal to minus 1, which implies a equal to minus 1. The value of, we obtain the value of a as minus 1. Similarly, if we put x minus 2 is equal to 0, x minus 2 equal to 0 means x is equal to 2. In the third equation, not 1, in the third equation, we have 15 into 2 minus 14 is equal to a into 2 minus 2 plus b into 2 minus 1. 15 into 2 is 30 minus 14 equal to 2 minus 2 is 0 and 2 minus 1 is 1, which is equal to b. which implies 16 is equal to b or b is equal to 16. Let us put the value of a, which is -1, in this equation number 2. Similarly, the value of b, which is 16, this can be also substituted in the equation number 2. Then we have 15x minus 14 upon x minus 1 into x minus 2, which is equal to -1 upon x minus 1 plus 16 upon x minus 2. Now from 1 and 4, we can write down 15x minus 14 divided by x minus 1 into x minus 2, which is equal to -1 upon x minus 1 plus 16 upon x minus 2. And this can be, so therefore y is equal to x square plus 3x plus 7 plus this value we can substitute over here, -1 upon x minus 1 plus 16 upon x minus 2. And if we differentiating n times with respect to x by considering n is greater than 2, we have nth derivative of y, which is equal to nth derivative of x square plus 3x plus 7 plus -1 upon x minus 1 plus 16 upon x minus 2. Let us separate these different terms. Nth derivative of x square, nth derivative of 3x, nth derivative of 7, nth derivative of -1 upon x minus 1 plus nth derivative of 16 upon x minus 2. Since here n is greater than 2, so clearly the value derivative, nth derivative of x square is 0, nth derivative of 3x is 0, nth derivative of 7 is 0. We are able to find out the nth derivative of these two terms. And we know that what is the nth derivative of 1 upon x minus a? It is n factorial -1 to the power n, a to the power n, x minus a to the power n plus 1. Here a is equal to -1. Here a is equal to -2. So we can put this formula. First, n factorial -1 to the power n. The value of a is equal to 1 because it is x minus a. So if we compare it x minus a with x minus 1, x is equal to a is equal to 1. X minus 1 whole to the power n plus 1 plus 16 n factorial n minus 1 to the power n, 1 to the power n divided by x minus 2 to the power n plus 1. Now, n factorial -1 to the power n is common in both the part. Therefore, we can take outside. What is remaining over here? 1 to the power n is 1. So only remaining is 1 upon -1 upon x minus 1 to the power n plus 1 plus 1 upon x minus 2 to the power n plus 1. Therefore, the nth derivative of x to the power 4 upon x minus 1 into x minus 2, which is equal to n factorial -1 to the power n, 1 upon x minus 2 to the power n plus 1 minus 1 upon x minus 1 to the power n plus 1. This is the desired nth derivative of the given function. Thank you.